So game number 1 says a company employee generates a series of 5-digit product codes in accordance with the following rules. The codes use the digits 0, 1, 2, 3, and 4, and no others. Each digit occurs exactly once in any code. The second digit has a value exactly twice that of the first digit. The value of the third digit is less than the value of the fifth digit. This might be the only time multiplication has ever appeared on the LSAT. I know you guys are all future lawyers, and some of you are a little freaked out by having some math on the test, but you know, I think third graders can handle this kind of math, so you guys should be able to do okay here. I'm going to write down my players. If I don't know what else to do, I'll always write down my players. So my players are 0, 1, 2, 3, and 4, and I'm trying to put them in order in a 5-digit product code. I have to use all 5 exactly once, just putting them in order. The second rule, I don't know if it's, I guess it's the third rule, that says the second digit has a value exactly twice that of the first digit. That's really the key to understanding this game, and this is a game that you can just absolutely smash. Okay, this is a game that some people are going to do in 5 minutes with almost no problem. And the way you do this game in 5 minutes is you realize that the first 2 digits can only be 1, 2, or 2, 4. If you did that, just that right there, I almost guarantee that you killed this game. Okay? That's the only way that you can have the second digit be twice the first using these 5 digits. We have a rule then that says the third digit is less than the fifth. So I might just make a little notation here. The third this is a less than sign, so the third digit is less than the fifth. I could do the same thing up here. Third digit is less than the fifth. And then I might go just one step further, which is that eliminates from contention like in both worlds, 0 now can't be last because the fifth digit has to be higher than, right? So in the first world, I've used my 1 and my 2. I'm left with 0, 3, and 4. So this has to be 3 or 4, and this has to be 0 or 3. In this world, I've used the 2 and the 4, so I'm left with 0, 1, and 3. This then has to be 1 or 3, while this has to be 0 or 1. Follow all that? Pretty simple. I like this game for teaching purposes because it's a good example of making 2 worlds, right? There's just 2 templates, and I think we all can see why this is a sensible solution to the game. We're going to always have to start either here or here for every question. It's better to just figure this out in advance rather than have to figure it out again and again and again for every single question. Number 1 says, if the last digit of an acceptable product code is 1, it must be true that what? So now here's how we use these 2 templates. The last digit is 1. If the last digit is 1, well, then I'm not in this world, because in this world the first digit's 1. In order for the last digit to be 1, I have to be in this world, and specifically, it's going to be a version of this world where it's 2, 4, 0, 1, and 3. This is the only way, as it turns out, to make the last digit be 1. Now I can turn to the question. It says, it must be true that what? Does the first digit have to be 2? Yes, it does. That's the answer. Now, if I'm not 100% sure, I could run through the wrong answers. B says, does the second digit have to be 0? No. C says, does the third digit have to be 3? No. Does the fourth digit have to be 4? No. Does the fourth digit have to be 0? No. So number 1 is A. Any questions about that approach so far? All right. I'm going to skip number 2 because I'm going to do the if questions first. So number 3 says, if the third digit is not 0. If the third digit is not 0, well, what world am I in if the third digit is not 0? Am I in world 1? Both, right? I could be in world 1, but I could also be in world 2. So here I'll just make the two diagrams. And I know a lot of people are like, oh man, that's so much work, but you know, it's just not going to be that much work. Okay, I could be in the 1, 2 world. I could also be in the 2, 4 world. If the third digit is not 0, then in the 1, 2 world, it's 1, 2, 3. And in the 2, 4 world, it's 2, 4, 1. Fifth digit's always higher than the third digit. So in this world, and again, if it's not 3, if 3 is here, then the 4 has to be here. In this world, if the 1's not there, then this has to be a 3. And now the zeros are here and here. That work would really, you know, when you get good at this, that work takes you 20 seconds maybe. The question then says, which one of the following must be true? If it must be true, it must be true both here and here. So let's check. The second digit is 2. If you had only made this world, you might think that the second digit does have to be 2. But in this world, the second digit is not 2. So it's not A. How about B? The third digit is 3. Again, in this world it is, but not in this world. C says the fourth digit is 0. Yep, that happened here and happened here as well. That's going to be the answer. Number 3 is C. Let's check again. D. Does the fifth digit have to be 3? Well, it could be, but it doesn't have to be. E says the fifth digit is 1. That's not even possible. So the answer for number 3 is C. I'll go back to number 2 now, because I'm done with all the if questions. So now I'm going to do 2, 4, and 5. 2 says, which one of the following must be true about any acceptable product code? I don't know. I have to look at the answer choices here. I can't make a new diagram. I'm going straight to the answer choices. A, does the 1 always appear before the 2? Look at your previous work. I've already seen the 1 be after the 2. So that's not the answer. How about B, 1 before the 3? Again, no, I've seen the 1 be after the 3. How about C? Does the 2 always have to be before the 3? Well, it was before the 3 here, and it was before the 3 here, and it was before the 3 here. And oh, by the way, if you look at your two starting templates, they always have to be either 1, 2, or 2, 4. And in either case, the 2 is going to be before the 3. So that's the answer. Number 2 is going to be C. Number 4, any of the following pairs could be third and fourth except. So we're looking at these two spaces, third and fourth. Any of the following could be third and fourth except. Any answer with a 2 in it would have been really good, right? Because 2 can never be third or fourth. But glance at the answer choices, there's no 2's anywhere. So third and fourth, which one's going to be a problem? I don't know. I'm going to have to just test them. How about 0, 1? I don't think that would be a problem. I think right here we could go 0, 1, 3, and that would work. So that's not the answer. Number 4 is not A. How about number 4B? How about 0, 3? Up here I think we could do that. Actually both places. So here it could be 0, 3, 4. Here it could be 0, 3, 1. That would work. So nah, it's not B. How about C? A 1 and then a 0. Sure, no problem right here. 1, 0, 3. That would work. How about D? 3 and then 0. Yeah, 3, 0, 4. That would have worked. So it's not D. E must be a problem. 3 and then 4. Oh, I see. And you can see it in this first template, right? If we put a 3 here and a 4 here, then there's nothing left for this spot. It would have to be 0, I guess. But then you'd have a last digit that's less than your third digit, so that ain't working. So the answer for number 4 is E. Questions? Number 5, which one of the following must be true about any acceptable product code? There's exactly 1 digit between the 0 and the 1. No. Previous work, I've seen there be 2 in between the 0 and the 1. I've also seen there be 0 in between the 0 and the 1. So that doesn't always have to be true. How about B? There's exactly 1 digit between the 1 and the 2. No, there can be 3 digits between the 1 and the 2 if we do it this way. C says there are at most 2 digits between the 1 and the 3. And if I look at this first template, I think that's not the answer. Because at most 2 digits, that means it's not possible to put 3 digits in between the 1 and the 3. But it is possible, because if I start off 1, 2, I could go 0, 4, 3, and then I'd have three spots in between the 1 and the 3. So the answer is not C. How about D? There are at most 2 digits between the 2 and the 3. Again, no, because I could go 2, 4, 0, 1, 3. So that's not the answer. Must be E again. There are at most 2 digits between the 2 and the 4. And yeah, you can actually see that from these 2 templates, right? I mean, here the 2 and the 4 are right next to each other. And here, the 2 is in the second spot, which means even if you put the 4 as far away as it can possibly go, there's still only going to be 2 spots in between those 2. So we believe that we can't ever get the 2 and the 4 spaced out by more than 2. So that's the answer. Number 5 is E. And I would consider that to be a pretty gettable game, despite the fact that it does have some higher math involved. All right, that's that.